So for problem number 1, we're asked to find the distance between 2 points. We're going to give the exact distance and an approximation to 2 decimal places. So for this, we're just going to use the distance formula of d equals square root of x2 minus x1, which would be 3 plus 1 since it's 3 minus -1, squared plus y2 minus y1 squared. This is equal to square root of, let's see, that'd be 16 plus 100. So this is the square root of 116. This is our exact answer, and our approximation is 10.77. Okay, for problem number 2, we're asked to determine if 3 points form the vertices of a right triangle. To do this, we need to guarantee that Pythagorean theorem holds. So Pythagorean theorem is just a squared plus b squared equals c squared. Okay, so that means that the lengths of the 2 shorter sides are going to be equal, or the square of the lengths of the 2 shorter sides are equal to the square of the length of the longest side. Okay, so we're going to find 3 different distances here. So first, let's have d1 be equal to the distance between point M and point P. So I'll do x2 minus x1 squared plus y2 minus y1 squared, square root of that. And this is going to be equal to the square root of 36 plus 16, which is equal to the square root of 52. Now d2, let's have that be equal to the square root, or the distance between point P and point Q. So that would be the square root of -1 minus 4 squared plus 7 minus 1 squared, square root of that. And that will be equal to the 25 plus 36, and that is equal to the square root of 61. Finally, let's have d3 be equal to the distance between point M and point Q. So that would be the square root of -1 minus -2 squared plus 7 minus -3 squared. Square root of that, it's going to be equal to the square root of 1 plus 100. That is equal to the square root of 101. So now let's have that 52, or the square root of 52 is the smallest of the 3 distances. And so we could say that the segment represented by MP is A. So if we were to take that length of A squared, that would be 52. If we did the same thing for B, that would be 61. And the last one would be 101. But if we actually add these together, we'd see that we'd get 113 equals 101, which is not true. Because the sum of the squared lengths of the 2 shorter sides of this triangle are not equal to the square of the length of the longest side, this is not a right triangle. Next, we're going to find the midpoint of the line with endpoints -2, -9, and -9,4. For this, we're just going to find the averages of the x coordinates and the averages of the y coordinates. So -2 plus -9 over 2 comma, -9 plus 4 over 2. And this is going to be -11 over 2 and -5 over 2. And that is our midpoint.
All right, for question 4, it says graph the equation y equals 1/2 x plus 3 by plotting points. Show the points you're using in a table of values. Show all work. All right, so we're going to start by making our table. Here we're going to have x, y, and then our point x, y. We're going to start by plotting -4. So when we plug in -4, 1/2 times -4 plus 3, and that will give us -2 plus 3, which equals 1. So our first point is going to be -4, 1. And if we do similar steps with -2, we get y is equal to 2. So -2, 2. For 0, we get 3. So 0, 3. And then for 2, we get 4, so 2, 4, and then for 4, we will get 5. So, if we were to plot this graph, it would look a little something like this: 1, 2, 4, 4. Right, so at -4, we would be at 1. At 2, we'd be at -2, we'd be at 2. We'd be here. Be here, and we'd be here. So our graph would look something like this. Oh, the point's a little off. But like that. So every 2x over, we go up 1. All right, number 5, find the x and y intercepts of the following equation. Show all work. So for our y-intercept, we're going to plug in 0 for x. So y equals 0 minus 2. And so that means the y-intercept is going to equal -2. So y in 0. And for the x, I set y equal to 0. So we have the absolute value of 2 equals 2, and so that means x is going to be equal to -2 and 2. So our x-intercepts are going to be -2, 0, and 2, 0. For the next problem, we're going to do the same thing. Y is equal to 0 minus 16. So the y-intercept is going to be equal to 0, -16. And then 0 is equal to x squared minus 16. So x squared is equal to 16. And x is going to be equal to the square root of 16, which is equal to the plus or minus of 4, because that can be, because -4 squared equals 16 and 4 squared equals 16. So that means our x-intercepts are going to be -4, 0, and 4, 0. So there are all our answers. Question number 6, find the x and y intercepts of the equation. Use the intercepts to graph a line should all work. Right, so we're going to do the same thing. To find the y-intercept, we're going to set x equal to 0. So 0 plus 4y equals 12. So y is equal to 3. So our y-intercept is going to be equal to 0, 3. And we do the same thing to find the x-intercept. Negative 2x plus 0 equals 12. So x is going to be equal to negative 6. So now I'm going to graph those. 1, 2, 3, 4, 5, 6. So here's this. 2, 3. Here's that. And so your line should look a little like that. All right, question 7. Given the function f of x equals 4x minus 3 and g of x equals x squared minus 2x plus 7 and h of x equals the square root of x plus 3, evaluate the following given values of x show work. So f of negative 3. So for this one, we're just going to plug in wherever x is 3, or wherever x is for a negative 3. This one's going to be like that. So that's going to be negative 12 minus 3 is equal to negative 15. All right, and now for this one, wherever we see a negative, or wherever we see an x, we'll plug in a negative 5. So that's going to be 25 plus 10 plus 7, which is going to be equal to 42. This one, we're just going to plug in a 13 every time we see an x. So 13 plus 3 is equal to the square root of 16, which is equal to 4. F of 4, so 4 times 4 minus 3 is equal to 16 minus 3, which is equal to 13. So there are answers for all of these problems. Question 8. Evaluate the function defined of f of x equals negative x squared plus 4x for the given values of x. Show all work. F of t. So this just means I'm going to plug in a t everywhere I see an x. So f of t is going to be equal to negative t squared plus 4t. And that's it, nothing special. Since we don't have a number, we can't solve for anything. So, question B, we're going to plug in f of a plus h. So, f of a plus h right, and now I'm going to FOIL this here. And switch all of the signs. And we can't really simplify anything else, so this would be our final answer. There we go. So, question 9. For each of the following, determine if the relation defines y as a function of x. So for this one, if it's a function, we have the definition that every x value has one y value. So we can use, for this one part A, we can use the vertical line test. We draw a line anywhere, and if that line goes through two y values for a single x value, then we know it is not a function. So we can take this line and we can draw it in random places, and we can see that it never crosses multiple y values, right? It never touches that blue line twice in a single x value, so we know that this is a function. So function. Same thing for this one. So for part B, we can solve this for y. Y is equal to negative x squared plus 7. And then we can draw that function. It looks like this, where this is 0, 7. Right, and then we can do our vertical line test, and we can see that that is a function. For part C, we have to check that if this x value has multiple y values, then it's not a function. And we can see here at negative 6, that it touches 2 y values. So that is the rule that breaks this, so this is not a function. So for this function, we can see that we have this y squared here. We can simplify this function a little bit to be y minus 3. And ultimately, this is the equation of a circle around the point 3, 0. So if we go up 3 here, we have a circle with a radius of 2. So this is what our function looks like, and then we can do our line test. And we can see that in multiple cases, we touch the graph twice in almost every location with the vertical line test, so this is not a function. All right, question 10, use the vertical line test to determine if a given relation is a function of x. So we use our vertical line test, and with our first line, we see this is not a function. For part B, we can draw as many lines as we want, and we can see that it is a function. And then for this one, we're good until we reach here. We go through 2 solid points here and here, so this is not a function. But everywhere else it is a function. If there was if one of those points was open, then it would be a function. But since they're both solid points, then it is not a function because of our vertical line test. Number 11, determine the x and y intercepts of the following function, show all work. So this is just like the problem earlier, where we can set x equal to 0 to find our y-intercept, so 0 minus 5, so y is equal to negative 5. So this is our y-intercept is equal to 0, negative 5, and then we do the opposite. 0 is equal to the absolute value of x minus 5, and we can solve that for x. And we know that the absolute value of 5, both 2 points that work for that is negative 5 and 5. So our x-intercepts are going to be negative 5, 0, and 5, 0. So these are the answers for part A. For part B, we're going to do the same thing. So y is equal to negative 0 plus 3. So y is equal to 3. The y-intercept is equal to 0, 3. And then set y equal to 0 plus 3. So we move 3 over. And then multiply by the negative sign. And then we square them. So x is equal to 9. And it can't be equal to -9 because we'd have to take the square root of a negative number, and that would give us an imaginary number, which we do not want. So the x-intercept is going to be equal to 9, 0, and not -9, 0. Number 12, write the domain of the following functions in interval notation. So, when we look at this problem, we ask ourselves, what would make this not a function? Or what x values can we not use here? What would break our function? So for part A, we have a denominator. And what we know for this denominator is it cannot equal 0, or else the function will be undefined. So we ask ourselves, where would the bottom equal 0? And that would be when x equals -7. So this domain is x cannot equal -7, or -infinity all the way to -7, and -7 all the way to infinity. So every number except 7. For problem B, we just have a quadratic. It doesn't have any places where there can't be an x value because it's just a quadratic. It goes on for infinity. It'll look like that. Its domain is -infinity to infinity. For C, we have another denominator. So that means where can this denominator not equal 0, and that's where the denominator equals 0. So x cannot equal 3 or -3. So x cannot equal -3 or 3, or -infinity to -3. -3 to 3, and then 3 to infinity. For part D, we have a square root. For our domain cannot have a negative square root, or else we have an imaginary number. So we have to determine where the square root becomes negative, and that's at 0. Right, so wherever the inside equals 0, and that's at x equals 4. And now we have to determine what side of, so if we draw at 4, if we plug in 0, we get the square root of 4, which equals 2, which is good. There's a check mark. But if we were higher, if we were at 8, we'd have the square root of -4, which is bad. So we know that our domain is on this side of the timeline, so 4 is the greatest number, so x is less than or equal to 4. Because we can't equal 4, that would equal 0. The square root of 0 is 0. So this domain would look like -infinity all the way to 4. Number 13, use the graph f of x to determine f of -2, and so on. So part A, determine f of -2. So that's easy. We just go and we find -2, and we go down to see what the y value is, and that's going to be -2. Next one, determine f of 3. So same thing, we go to 3, and then we go down to its y value, and that's going to be equal to -1. Find all x values for where f of x is equal to -1. So this is our y value, so we go to -1, and we can go over here and see that it's at 3. And this way we can see that it's at -1. So x is equal to -1 and 3. Find all x values for which f of x is equal to -4. So we go down to -4, and we go this way, and we see it doesn't reach that way. Here we have an arrow that shows that it just stays flat. until infinity, and then if we go this way, we can see that happens at x equals -4. Determine the x-intercepts. So everywhere that where y equals 0. So we go to this line, x equals 0. And see that happens at the origin 0, 0, and at x equals 2. So our x-intercepts are going to be 0, 0, and 2, 0. Determine the y-intercepts everywhere it touches the y-intercept, and that's going to be just at the origin, 0, 0. Determine the domain of f. So, as we can see, f on this side of the graph goes downwards to -infinity, and this way goes all the way that way to infinity. So we know that the domain of f is going to be -infinity to infinity. And we don't have any restrictions or anywhere else where x cannot be, as shown by the graph. H, determine the range. So determine all of the y values that it can be. So we can see that everywhere above 1, above this point is blank. We don't have any y values up there. So our top is 1. And if we go down, we can see on this way, it's going to -infinity in the y direction. And this way, it's staying at -2. So that means our highest value is going to be 1, and our lowest value is going to be -infinity. All right. Question 14. Graph the line represented by each equation. So for part A, we have to get it into a form where we know how to graph the line. So 2y is equal to -4x plus 2. And then divided by 2, y is equal to -2x plus 1. So if we were to draw that, I would know to start at 1. So start at 1, and we know that for every 2 y's, we go over 1x, and it's negative, so we're going to go in a negative direction. So we're going to go over 1 and down 2 to here, over 1, down 2, then we're going to go up 2 over 1, and we're going to have a line that looks like this, with the slope of -2. For B, we have y equals 1, so that means that it's going to be a line strictly at y equals 1. Every single x value is going to be equal to 1, or every single x value is going to have a y value equal to 1, so we just have a straight horizontal line right there. For part C, we can divide the whole thing by -3 and gets x is equal to -4. And so to draw that line, we know that every y value is going to have an x value of -4. This is A, B, and C. Determine the slope of each of the following show at work. A line that passes through the point -4, 1, and to -2. So we know that we can use our equation m equals y2 minus y1 over x2 minus x1, and we can just plug in those points. Here we have 1 minus 2 over -4 minus 2, which is equal to 3 over -6, which is equal to -1/2. So that is our slope for point A. For for part B, we have a line passing through the points 3/4 and 2, and -3/17. So use our same equation, which is 17 minus 2 over -3 over 4. And so what we can do is we can change this number here to be over 4. So this can be -12 over 4 minus 3 over 4. It's going to be equal to 15 over -15 over 4. And then we have two fractions here. So we are going to multiply the bottom by the top by the reciprocal of the bottom. So 1 over 15 times -15. And these cancel out, and that leaves us with -4. Those 15s reduce out. A vertical line. So if we were just to draw a vertical line, say here, the slope would be undefined since it is straight up and down. We can't determine what a straight up and down line would look like. It could be 1,000, it could be 1,000,000, it could be 1,000,000,000, it could be 1,000,000,000,000. So we can just say that it is undefined. A horizontal line, however, has no change in y. So we can say that the slope is equal to 0 since the y is not changing. And these are shown in our equation. The slope is equal to the change in y over the change of x. And so in C, the y values are changing. The x value is always the same, so the y value. So that means that the x value, the change in x is equal to 0, but we can't divide by 0, so that is an undefined function. But in D, the y values are changing, or they aren't changing, and the x values are changing. So that means that the change in y is equal to 0, which we can't have. Is equal to 0. So m is equal to 0. If that makes any sense. So part E, it gives us the slope right here. We have the equation y equals mx plus b, and here's our m right here. It is 2/3. And for this next one, we're going to do the same thing, except for we need to get it in the right form, and then divide by 4, and we get y is equal to -3/4 x plus 1, but that doesn't matter because we have our y right there. All right, problem 16, write the equation of the line and slope-intercept form that passes through the point -1, -4, and has a slope of 3. So it gives us the slope, so we have y equals mx plus b. We know what this y is going to be 3. So y equals 3x plus b. And we can use our point to find out what b is. So -4 is equal to 3 times -1 plus b. And we have -4 is equal to negative b. So b is equal to -1. So our final equation is y equals 3x minus 1. So question 17, given the function defined by f of x equals x cubed plus 2, determine the average rate of change on the interval -3 to 0. So what we need to do is find our points at -3 and at 0 so that we can use our slope formula to find the average rate of change. So if we plugged in -3 cubed plus 2, you get 3 cubed is equal to 9 times -3 plus 2, which is equal to -27 plus 2, which is equal to -25. And this one we have 0 cubed plus 2, which is just 2. So now we can plug into our slope formula. Y2 minus y1 over x2 minus x1, and that should be equal to 2 minus 25 over 0 minus 3. So that is equal to 27 over 3, which is equal to 9. So the average rate of change is 9. So that is all for part 1 of your exam 2 review. There are going to be 4 more parts all the way up to part 5. So we will see you in the next video.